Hello guys, how are you? Are you okay? So I'm doing the recording in the outside of the classroom. I really miss that there are a lot of students playing here or working in here. Okay, so this is my last video in this chapter. So I hope that these videos can uh, help you to understand this topic completely. In this video, I'm going to give you several learning objectives. After you can focus on this, then after the end of the meetings or the end of this video, you can understand this all. These are the important terms, okay, that you have to understand in these videos before you watch all. First is about the energy. I think you have learned this, and energy is the ability to do the work. The electrical energy, yeah, this is the energy conversions. The energy transfers to an electric load by moving the electric charge. Joule is the unit for energy. Don't forget. Because joule is so small, sometimes we use the larger unit. So in electricity, we use the watt hour or kilowatt hour. Okay? Kilowatt hour. I think this is not the new things for you, yeah? Have you ever seen this kilowatt hour in your home? So that's all the important term in this chapter. In my last video, there is this formula. So where is this formula come from? Then I have already explained in my last video. Okay, remember the energy is the voltage times by the electric charge. Then you have learned that the electric charge is I times T. Okay, so by substituting the Q with I times T, then you get these equations. So phi is the volt, yeah, voltage. The unit is volt. I is the electric current. The unit is ampere. Then T is time. The unit is second. The unit of E is joules. From this formula, we can derive another formula again by using the Ohm's law. Do you still remember the Ohm's law? Voltage equal to I times R. Then you can replace the voltage in here. So E equal to phi IT will be replaced by I times R. So I times R times I times T. Then you get the new equation. E equal to I squared times R times T. Okay. But you also can replace the current. We learned that the current is phi per R, right? So you can replace the I in here. So become E equal to phi times the I we change with phi per R times T. Then we get the equations. Phi squared per R times T. This is the second equations. Okay, so there are three equations already. One, the first one, the second one, the third one. So which one that we are going to use? We will use all of them. Depend on the question's informations. If the question tell you the I and the resistance, then you use the I and the resistance. If the question give you the voltage and the resistance, then you use this formula. But remember, the T must be in second, yeah, because you use the joule as the unit. Look at these questions. Calculate the energy released from the battery in a flashlight bulb that was switched on for 4.5 hours. The voltage drop was 6 volt and the current is 0.35 ampere. So we can write down what can we know from the questions. the volt, the phi is 6, the current is 0.35, and then the time 4.5 hours. So if these three items is given here, then which formula that we are going to use? There is phi, there is I, there is T. So you can use phi I T formula. Okay, so where is the problem with our number and the formula? The time. Okay, this one, you have to convert this into second. Okay, yeah? I think to convert into second will not be difficult for you. Yeah, 1 hour is 60 minutes. 1 minute has 60 seconds. So 1 hour has 3,600 seconds. So 1 hour, yeah, 3,600 seconds. So 2 hour will be this. So 4.5 hours will be how much? Just count it. Times by 4.5. You get 16,200 seconds. Okay, then by using this formula we get the answer. Yeah, so the energy released from the flashlight is 34,020 joules. The next is the red, how fast the energy is used, we call as power. Okay, I think you have learned it in grade 8, right? So the power is measure of the red. Okay, so where is the power formula come from? Formula power, yeah, come from the power. This one, power is equal to the energy per time. Have you ever got this formula? I think yes, in grade 8 you have learned it. Okay, so because the power is equal to the energy per time, okay, this is the energy over time, then you have got the previous formula. Power is phi, energy formula is phi IT, right, over time. You can cancel the time, so you get the power is phi times I, yeah, in this triangle. But by using the other's energy formula, you can count the power. Okay, you have learned it. Same again, power is energy per time. Okay, then the energy is I squared times R times T over T. Then you can cancel the T. So you get the new equation, power is I squared times R. This is the second formula. Okay, then you can get the next formula again. Yeah, because there are several formula of the power. Power is energy. Yeah, energy again. Energy is phi squared per R times T and over T. You can cancel it. Then you get the power is phi squared per R. So there are three formula that you can use, depend on the information that is given in the questions. So you have two options. You memorize this formula or you derive it in the test. I prefer to derive this formula. Okay. Example, yeah. Calculate the power of a vacuum cleaner if the operating voltage is 124. The current flowing through it is 7.9 ampere. So we see that the question has already give you the voltage, right? Voltage and the current. So you can use this equation, V times I. Okay, the power is 120 times 7.9, and you get this. Then the unit is watts. Okay, so the power used by the vacuum cleaner is 948. Next, calculate the voltage of the computer that has 600 watt of power. So this is the power. okay, and the I is 1.9 ampere. So yeah, I think you can calculate it easily. Yeah. So the voltage of computer is 315.84. How about if the electric usage in our home? I think all of your house must have these two devices. What is that? This one, and this one, right? Okay, this is the one that you are going to, the one that the officer or the PLN people will come and check your usage here. Okay, and this one is the digital version one. You can see the one that in your house. Okay, every house must have these two. Okay, so this is to record our electric usage. Okay, and from the recording we can get how much do we have to pay for the electric bills. So this is my home electric bill. Okay, I I erase the number. Okay, so this is the real one, yeah, the one that my house spent. Okay, you see the unit in here. Okay, you see this number, this one, there is a pemakaian. Okay, this one, and there is a price. So we are going to study how can they get this price. Okay, so the usage, the unit is kilowatt hour, right? This one, yeah, kilowatt hour. So what is this, guys? Is this the power or the energy? Okay, you can see here kilowatt. Kilowatt is power times hour. Hour is time. So what is this? P times T. This is the energy. So the PLN or the electricity is charged, or the cost is depend on your energy usage at home. Okay, yeah? Then how can we get this price? It means that there will be conversions for each kilowatt hour that you can see from this table. Okay, my house is R2, so this is the one that I use, and the price is this. So to get the price, then I just times by the total usage of the energy. In here is 353 times by 1000 and around 1500, right? But why my bill is exceeds than the calculation? You can count it. If 353 times by 1500, then you get around 500,000, because there is an extra charge. Okay, there is an extra charge that you need to pay each month. Okay, so in our calculation we ignore the extra charge. Okay, we just count it by using this formula. Okay, find the kilowatt hour, after that times by the price, then done. Okay, so we can say that the cost is kilowatt hour times price per kilowatt hour. Okay, this is the example. Yeah, there is a house, the power is 1300 watts. Okay, and then it's use the lamp. There are 3 lamps with 25 watts and 4 hours every day. So we have to count the usage. Okay, so if there are 3 lamp, so the lamp is 3 times 25 watts, right, times by 4 hours every day, then we have to count the daily usage. So this is equal to 300 watt hour. Okay, now there is another lamp again, 10 watts lamp. So lamp, so only one lamp, 10 watts times by it's 11 hour, right? So 110 watt hour. Okay, and a televisions, yeah, TV. How many television here? One times by 100 watts. Okay, and 5 hours a day. So you get 500 watt hour. Okay, and after that, television already. In addition, there is an iron, 500 watts, 2 hours a week. Okay, if the one that a week, we postpone, yeah, a week. So there will be 500 of the iron, 500 watts times 2 hour. So 1000 watt hour. This one is in a week. Don't forget, you cannot join with here. This is a day. Okay, a water heater. Yeah, heater. 201 times 200 times 3 hours a day. You get 600 watt hour. And then the air conditioners, AC, is 4 times by this one you have to be carefully. Okay, the water heater also, sorry, water heater should be wrong, may not, this is not the phi, this is the r. Alright, so this is the I. Then you cannot use this one, so the heater must be erased, yeah. Then how to count it? So if the water heater is 200 ohms, then you have to find the energy. So 200 ohms, so the R, right? Yeah, we assume that there is no any current and there is no any voltage in here, then we assume that we use the standard voltage. Standard voltage in Indonesia is 224, right? So the heater, we use this formula, okay, phi square per R, okay, to count the P. This one is the P, yeah, times T. So 220 square divided by the R is, the water heater is 200, okay, times by 3 hours. Then we get the usage for a day. Okay, yeah? And the AC. If the AC, okay, the I is given here. Okay, the I. So you can count it by using phi I, right? So you can use phi times I times T. So the phi is, use the standard voltage, 220 times by the I is 4 times by 8 hour. So this one is 726 watt hour. Then this one is 7040 watt hour. So you add it. This is the total usage in a day. So you add it. Then the result is, the total usage for a day is 7,000. Sorry, should be 8,676 watt hour. Okay, then how to find it in a month? Then you have to times by 31 because January is 31 days. Then we get, so in a month for the daily, from the daily usage, you get 219,876 watt hour. Okay, but don't forget there is an iron here. Okay, so if we assume that, yeah, 1 week is equal to, I mean that for a week is equal to 1 month. This is our assumption, yeah. So you can times this by 4. Okay, so the total is 219,876 plus 4 times 1000, so you get 4000 watt hour. You get 223,876 watt hour. Then change into kilowatt hour, yeah, divide by 1000, don't forget, change into kilowatt hour. We get 223.8676 kilowatt hour. Okay, then the total cost will be 223.876 times by the cost for per per kWh, per kWh, times 300. So I get 67,162.8 rupiah. So this is kind of cheap because only 300 per kilowatt hour. Okay, yeah? So remember guys, you have to count in a month. This is the one that I usually find mistake in here. If there is no information how many days in a month, then we assume that 1 month is 30 days. But this question tells us about the January. Then you can check in the calendar, the January is 31. Okay, and the next is, if the question said that a week, then we assume that 1 month consists of 4 weeks, then you times by 4. Don't forget to convert it into kWh, so you have to per 1000, okay, to convert the watt hour into kilowatt hour. So guys, please try to do these questions, yeah, the task 6. Okay, number 1, number 2, 3, 4, 5, 6, 7, and 8. So try to do it by yourself, yeah, in the OneNote tabs. Okay, do it in the homework task 6. Okay, and then don't forget to take a note from your watching video. After you watch the video, take a note so I know that you are watching the video. If you didn't take a note, how can I know what is the evidence show that you was watching my video? I really hope that you become a mature learner, a pembelajar dewasa, yeah. So you will learn by yourself, not because of the punishment. I don't like to give the punishment, but I hope that you learn by yourself. You have the self-motivation. That's all guys, my video. Don't forget to do your task.